wilderness taking a hike. So the chat question is, what is the best hike you've ever been on? I don't know if we have any hikers in here, but I would love to hear about your best hikes. I really love hiking. It's one of the things I like to do. So would love to hear yours. Fun fact, 30% of the world's highest waterfalls are in California, which I had no idea that they are in California. I've been to a few of them, but not the highest ones. But 3 out of the top 10 highest waterfalls in the world are in California. So right here. And then another fun fact about hiking, I guess, or like wilderness, is that the sequoia tree, one time in 1937, a sequoia tree fell in Sequoia National Park, and it was so big, it's 275 feet tall and 21 feet in diameter. And it fell down, and so they just made a tunnel through it. So you can see that. That's what this like picture down here is. It's pretty cool. I've never been there, but it looks really cool. And then I guess this one's more like tourism-y. So they like cut a hole in it so you could drive through it, which is pretty awesome. Some people have never been on a hike. Actually, technically, everyone has been on a hike because a hike is just defined as taking a walk. So really, like you could take a hike from Expo to school. So if you've ever walked to school, you've taken a hike, or walked to like anywhere. Maybe you could take a hike like from the car to the grocery store or something when you park. A few awesome ones, Eaton Canyon. The best one was when my family and I went to Eaton Canyon and my sister fell in the water. Excellent. Yes, I have also been to Eaton Canyon. I got in the water on purpose, which was cool. The tree reminds me of that Running Tombs game. I don't know if I've ever played that game. Sounds like fun. Yes, everyone has definitely taken a hike. I know some people like the wilderness hike. Some people are more like city hike people. If you've ever done like Griffith Park, that's a hike. Zion National Park is an amazing park. Utah has some really beautiful hiking trails. That is for sure. Yeah, definitely love hiking. I think it's like super important, and it reminds us that we should save our environment because like it's just so beautiful and peaceful out there in the wilderness. If you know Roxana Montiel, it's her birthday today, so wish her happy birthday. It's Josh Wise's birthday tomorrow. You can wish him a happy birthday tomorrow if you see him or know him. So thank you, Gallie, once again for dropping in that chat. We are going to jump in. We have 3 things on the agenda today. The first one is announcements. Then we're going to do notes and assignments. So a pretty normal day today. Fun fact about cows. Are you ready? This is random, but fun fact about cows. Cows, like humans, form close friendships, and they choose to spend much of their time with 2 to 4 preferred individuals. So like a small group, they make like their own little family. And they also hold grudges for years. Apparently, if a cow gets mad at you, it's going to be mad at you forever. And sometimes they can dislike particular people. So the cow doesn't like you. Apparently, it's no good. Cows. Who knew? Interesting fun fact about cows. Cool. That brings me to my next thingamabob. Sounds a lot like humans. I agree. Sounds a lot like humans. Great. I just have to pause. You guys did an amazing job on the quiz. I was so proud of you, especially because in the past, this has not been like a particularly easy thing to teach or for my students to understand. So I'm giving myself a pat on the back for teaching you really good. You should give yourself a pat on the back for just like rocking it out and doing really, really well. So you'll see the averages here for quiz 11. That was our worst one, was the factoring polynomials one. We just had like a little bit of a struggle with a few of the factoring, but not a big deal. Quiz 12, we got a 91. Quiz 13, our collective class average was a 93. And for graphing was a 90. So I am super proud of these. Question from the chat, are we going to be able to retake exams? Yes, of course you can retake an exam. If you would like to retake, please just shoot me an email. Because we did so well, I did not create like full class-wide retake parts. So just shoot me an email if and let me know which of the quizzes you would like to retake, and I'll send it to you directly. I also wanted to shout out these 10 individuals: Marissa, Kayla, Kiara, Fatima, Galilee, Janet P, Kimbo, Layla, Miriam, and Mia. You guys got straight A's on your quizzes, all 4 A's. So really, really impressive. Great job. I did leave comments on every single person who turned in their quiz. So if you go into Canvas, you can see some people's. I left you like comments on your Google Doc. Some people I left you comments in like the comment section, and then some people have little like little notes that are attached to the picture. So for some of you, you're gonna have to actually like click on the picture to see my notes. But I did leave a comment for everyone. So please do check your comments because I spent a lot of time typing them. So hopefully you'll be able to see that. Are there any questions about the quiz? I have 2 individuals who have not turned it in. Please, please, please turn it in because it's in the quiz category. So it's in your 30% category. So I don't want you to lose those points. Please turn it in. Awesome. Cool, friends. All right, we're done with announcements. We're gonna jump into our notes. Before we jump into our paper version of the notes, I do want us to jump into a stand. In my classroom, I call them stand and talk. It means that we literally stand up and we talk to someone who doesn't sit next to us. We're gonna do like some version of that on this Jamboard. So if you could go ahead, I'm trying something new, so forgive me if this doesn't work. If you could go ahead and go to that link on from the chat. You should, when it loads, you should see something that joins like this. Oh, Walter Pino joined. Sweet. David Lopez joined. Excellent. I can see a whole bunch of you have joined, so thank you. It's just like look, it's announcing you as you come in. So this is what's called a Jamboard. A Jamboard is like a gallery walk, kind of, where you like have little Post-it notes or sticky notes and you like stick your note up there. So there are 3 slides. I'll just show you how to do this really fast. There are 3 slides. You can, oh, I see someone moved my sticky note. You can go to each of the 3 slides by clicking this button up here. And then you can contribute to the Jamboard by pressing either the sticky note button, which allows you to like type your response here and you can choose a color here, or you can go to the text box option and then click on the screen and it will let you like type, and you can change like just the color of the font in there. Okay. So what I would like for you to do is on at least 2 of these pages, you don't have to respond to all 3, you can if you want, but on at least 2 pages, so either page 1, 2, or 3, I don't know who made page 4, don't go to page 4. On page 1, 2, or 3, I want you to respond to, is this mathematically correct, right? And like, will it always work? Why or why not? So for example, in this one, hey, come back here. For example, in this one, the person took 29 over 95 and they crossed out the 9 and they got 2 over 5. So is this mathematically correct? Tell me on the board. Is this mathematically correct? Will it always work? Why or why not? Right, so you're going to be typing. It's okay if you type something similar to someone else, but you're going to choose to add a text box or add a sticky note on whichever page you'd like. Do we have edit access? Can someone come off mute or tell me in the chat if you have edit? Oh, I know that you do because Kiara has been moving my picture. So you should be able to edit. So I'm going to give you 2 minutes to think about this. You're applying on 2 boards. Thank you, Kaylin. Appreciate you. You're applying on 2 boards. Go ahead and try. You can move your sticky note around. Yes, great job. Keep it up, y'all. if you're struggling to think why or why not this might work, you might start by substituting some numbers in for the x on page 2 and 3. Try substituting some numbers for x. I'm seeing a lot of awesome work on page 1. Page 3 is feeling very lonely. Check out page 3 if you can.
Hey, miss, I'm back.
Awesome, Josh. We're in pre-calc now, so you're free to go.
Oh, okay, sounds good. All I need to
Wonderful.
do is a notes for your assignment 14.
Amazing. Can you submit it now and then I'll take a look at it once the notes are in?
All right, sounds good.
Cool. Thanks, Josh. See ya. All right, team. Thank you for engaging in this way. I'm loving watching I've been watching these like post-it notes like turn around and change directions, and I appreciate them. So we seem pretty convinced that this is not correct, this page 1, right? So pretty sure. One of the reason that I'm thinking about this, because I know we felt like I don't know how to explain why, is like the 9 is in the ones place and the 9 on the denominator is in the tens place. So we're basically crossing out 9 and 90, which we can't really cross that out, right? Also, many of you guys stated that like if you divide 29 divided by 95, it doesn't equal 2/5. We can just think about it like this is basically like 30 over basically 100. That's like 3/10. And this is 2/5, which is like 4/5, which is 4/10, right? So we know, we feel mathematically inside of us that these are not correct. So I agree with most of the post-it notes here that say like this is not correct. I also appreciate my humans who are like separating all the post-it notes out. I appreciate you. Okay, so then on this one, I have some yeses. Yes, this is mathematically correct. I think actually everyone says that this is mathematically correct. I would pose this situation to you. X just stands for a number, right? X stands for a number. So we have X plus 2 over that same number, X plus 5. So here's my situation to you. If I plugged in the number 3, right? If I plugged in the number 3 for X, would this be equal to 2/5? would it be equal to 2/5? So if I put 3 plus 2, that would be 5 over 3 plus 5, that would be 8. So 5 over 8. Is 5 over 8 equal to 2/5? No, it's not, right? Okay, let's try another number. What about 10? So 10 plus 2, that's 12, right? 12 over 10 plus 5, that's 15. Is 12 over 15, is that the same as 2/5? No. So actually, we can't do this, right? So all of these post-its that are saying yes, I actually disagree with all of you. Uh-oh, sorry, right? I disagree. And I would say, no, this is not mathematically correct. Wow, can't spell. Mathematically correct. Because if you substitute in, don't judge my spelling. If you substitute in a number, it will not be equal. That's what I'm saying. All right, I'm gonna post it. I'm gonna post it in pink because that's my face. All right, so mathematically, it is not, wow, it did not work. I don't know what happened. Anyway, oh, it's up here. So this one does not work. So the idea here is that when we're adding, when an X is added to another number, we cannot cancel it. We cannot cancel it. Let's check out multiplication, right? So some people are saying, no, they don't think this is gonna work because the X is the number as well. The 2s and 5s are just multiples. The X is attached. Let's try some numbers. All right, if I put 3 in here, if I put 3 as my X, 2 times 3 would be 6 over 5 times 3 would be 15. Is 6 over 15 equal to 2 over 3? Or sorry, 2 over 5. Is 6 over 15 equal to 2 over 5? Yes. Someone who's typing yes. How do you know that they're equal to each other? Someone come off mute. Don't talk to me in the chat. Come off mute.
If you divide the top and the bottom by 3, you'll get 2 over 5.
Yeah, for sure. Did anyone do it in a different way besides simplifying? Oh, I mean, you can plug it in your calculator, right? If you plug it in your calculator, 6 over 15 is going to give you 0.4 and 2 over 5 will give you 0.4. Both of those will be the same. Okay, so that one seems to work. What if we did, what if we put in 10 here? If we had 2 times 10, that'd be 20. And 5 times 10, that'd be 50. So 20 over 50. Is 20 over 50 the same as 2 over 5? Yeah, it is, right? Okay, let's try one more just for kicks. 5. Let's try 5. 2 times 5, that'd be 10. And 5 times 5, that'd be 25. Is 10 over 25 the same as 2 over 5? Yeah, right? It is. So it seems, even though we were not allowed to do it with the addition here, right? We are allowed to do it with the multiplication here, right? And the reason why is because this is multiplication and division, and those are opposites of each other, right? And I like to think of it as this one is addition, right? Those are being like locked together, added together. And then division, that's not opposites of each other, right? We have to do that in a particular order. We have to do the addition first and then the division. Where in this case, we have to do the multiplication or we can do the multiplication and division in different order, right? Because they are the same thing, right? So very interesting. Thank you so much for participating in my Jamboard. That helped me see so much of your thinking. So I super duper appreciate that. We are going to jump over to our notes. If you would, I'm going to grab my iPad so we can take them on paper. If you would prefer to type on them, you're more than welcome to type on this document. If you would prefer to not listen to me right now, you can also listen to me from the video. So if you want to jump off, and watch the video notes, you are welcome to do that at this time. Otherwise, I'm going to get us ready for the video notes by switching my screen to the video notes. Go ahead and share here. Come on, you can do it. There we go. Cool. All right, let me pull up that chat box one more time so I can see it. All right, so today we're going to work with multiplication and division, and we're going to work through some factoring and then canceling. So basically, what we learned on the Jamboard was that if we have like 25 over 35, we can't just cross them out. That's a no-go. We can't do that because that does not simplify to 2 over 3. If we have x plus 2 over x plus 4, we cannot cross out the x's. That's not allowed. It does not equal each other. But if we have 3 times x, or just 3x, and 5 times x, then we are allowed to cross this out, and it would be equal to 3/5. So this one is allowed. We're going to keep that in mind today. Okay. So for those of you taking notes at home, we've got notes 15. We're going to follow 4 distinct ideas here. We're going to factor first and foremost. We're going to get it into smaller pieces. We're going to cross out any common factors, anything that's the same on top and on bottom. We're going to rewrite the leftovers, and we're going to determine some excluded values. Those are our 4 steps for today. So I want us to think about our 4th grade fractions. By 4th grade fractions, I mean like fractions that we learned in 4th grade. So when we are simplifying, many of you guys talk to me about like, okay, I would divide by 5 and divide by 5 like this, right? Another way that you could think about it is this 20 is 4 times 5, and 45 is 9 times 5. So then if I cancel the 5, or if I divide them by each other, I would get 4/9. 4/9 is my answer. That's the same as what you would get if you divided by 5, you would get 4. If you divided by 5, you would get 9. So 2 methods, they work out the same way. So what we're going to do is break these things into their pieces, and then we're going to cross out anything that exists on the top as well as on the bottom. So we'll start with this one here. How could I factor the top portion? It's a trinomial. I need to put it into 2 pieces. How could I factor? What could I do? Feel free to come off mute if you feel comfortable. Type it in the chat if you wish. In the chat, we've got x plus 1, x plus 5. Yes. X plus 1, x plus 5. We're thinking of 2 numbers that multiply to get 5, add to get 6. That's going to be 5 and 1. All right. And then on the denominator, how could I break up the denominator? I have x squared minus 25. So I recognize the difference of squares. I have x plus 5 and x minus 5. Yes. X plus 5, x minus 5. Awesome. So I've done my first step. My first step was to factor. Right? My second step is to cross out common factors. So just like we're able to cross out the x's here, we're not able to cross out like an individual x and leave the 1 and 5. However, if we have a common term, a term that's on the top and a term that's on the bottom, then we are able to cross out that entire parenthesis because that parenthesis is being multiplied. So what I can do is I can say, okay, x plus 5 and x plus 5, those will cancel each other out. X plus 5 over x plus 5 is equal to 1. So they simplify to 1. So that's my second step, crossing out the factors. My third step is to rewrite the leftover. So rewrite what's left over. I have x plus 1 over x minus 5, like that. So that's going to be the first part of my answer. I'm going to put a comma after that. And then I need to determine my excluded values. Excluded values, you may remember from Algebra 2, are any numbers that the denominator is not allowed to be. And the reason that they're not allowed to be these numbers is because I don't want to have to divide by 0, right? So I don't want it to be dividing by 0. So I don't want anything in the denominator to make 0. So if I put in a -5 here, so I have x plus 5. If I put in a -5 right here, that's going to be -5 plus 5. That'd be 0. 0 times anything is 0. And dividing by 0, if you do that on your calculator, you're going to get undefined, right? So one of the things is that x is not allowed to be -5. It's not allowed to be -5. Nothing on the denominator can be -5. And then the other thing that it's not allowed to be is +5. If I put in +5 here, 5 minus 5, that would make this 0. Or if I put it in here, 5 minus 5, that would make this 0. Whole thing is 0, and we have an undefined situation on our hands. So this entire thing is our answer here. The entire thing. So this part, I suppose, would be like our answer. And then this is the warning, right? That's the warning. We're saying like, this is our answer as long as x is not -5 or +5, right? So this is our answer as long as those x's do not exist. If those x's are true, that makes this entire problem like explode, I used to say, right? I don't want my problem to explode, so I have to limit what types of x's there could be. I imagine that there are some questions. What questions do we have thus far? Yeah, good question. Okay, so the question is, where do we get the 5 and the -5? Okay, so you know how there's like, when we divide by 0, when we have a 0 in a fraction, it becomes kind of funky. So 0 divided by 2, I have 0 things in my hand. I cut them into 2 sections. Now each section has 0 things. So this is just equal to 0. However, if I have 2 things in my hand, here are 2 pens. I have to divide them into 0 groups. If I put them together, they're in 1 group. If I split them apart, they're in 2 groups. They each have 1 piece. But there's no way to put them in, to take these 2 items and put them into 0 groups. In fact, you can ask Siri, and Siri will be like, the answer is undefined. She used to make a cookie joke, but I think they wrote that out of her code. Anyway, so 2 divided by 0 is undefined. So if we have a 0 in the denominator, we have a problem. So what we have to be careful of when we look at this section, when we look at the denominator, is we have to say like, these things are not allowed to be equal to 0. This one's not allowed to be equal to 0, and that one's not allowed to be equal to 0. So what would make this 0? A -5 plus 5, that would be 0. What would make this 0? 5. 5 minus 5, that would be equal to 0, right? So we don't want the bottom to be equal to 0. So that's how we came up with the -5 and the +5. It's basically like the opposites of the factors that are in the denominator. Does that help us with that idea? Awesome. Glad to hear that. Thanks for that question. Let's try another. I think we're going to have a good time. So that's when we're simplifying. We're going to do basically exactly the same thing with multiplying and dividing. There's one different step because there are 2 fractions being put together. When I am multiplying fractions, do I cross multiply or do I multiply straight across? Can someone remind me? Does anyone remember? Trick question. We do not cross multiply. Cross multiplying is when you have something like this. Equals 4 over x. That's the situation where we would cross multiply, like 1 times x and 4 times 2, like that. I actually hate cross multiplication, and I wish I could go back in time and like delete it from your brain, because it does not help us. And it's mathematically like a trick. I don't love it, but we do multiply straight across. Yes, thank you, someone privately messaging me. We multiply straight across. So we do 4 times 1 times 4 would be 4, and 2 times 20, 2 times 10, which is 20, like that. And then we reduce or simplify. So dividing by 4, we get 1 over 5. 1 over 5. This is how we would multiply our fractions, our 4th grade fractions or 5th grade fractions. We would multiply straight across. We're going to do the exact same thing when we're working with a problem like this. We are essentially turning this into one long fraction here. So we have this thing times this thing, and we have this thing times this thing. I'm going to go ahead and break down each piece. So x plus 3 coming straight here. How could I break down? I need to break this into smaller pieces, like 2 smaller pieces. I need numbers that multiply to get -6 and add to get -1. Anybody got me? -3, +2, yeah. X minus 3, x plus 2. Sweet. All right, I'm going to take this denominator here, x squared minus 4. I recognize as the difference of squares, x plus 2, x minus 2. So I have x plus 2, x minus 2. And then finally, I have this last piece of the denominator there. The numbers that multiply to get 3, add to get 6. I'm sorry, multiply to get 9, add to get 6, which is 3 and 3. Yes, thank you, Fatima. Thank you, Galilee. X plus 3, x plus 3. Okay, so we broke down everything into its smallest pieces. Everything's being multiplied together. So now I can do that next step of canceling anything that has the same factor, the same multiplier on top and on bottom. So I'm going to go ahead and say, okay, I see an x plus 3 that can be canceled with an x plus 3. I see an x plus 2 that can cancel with an x plus 2. And then I have an x minus 3, no options, x minus 2, no options, x plus 3, no options. So these 3 are left over. I have x minus 3 on the numerator, x minus 2, x plus 3 on the denominator. So this is my answer as long as x is not what numbers? What numbers is x not allowed to be? Not allowed to be +2, for sure. Not allowed to be -3, for sure. There are 2 other numbers it's not allowed to be. Yeah, also +3 and -2. So I would probably write this as -3, -2, +2, and 3. For those of you who got the 4 answers, where did all 4 of those answers come from? I know where the 2 came from and where the -3 came from, but where did the other 2 answers come from? It's not quite absolute value, although that's a good thought. The other ones that we crossed out, the denominator, yeah. So anything that we crossed out in the denominator, anything in the denominator at any point is going to be a problem for us. So if we had, so x is not allowed to be -2, x is not allowed to be 2, X is not allowed to be -3. And did I write that one wrong? Oh, did we cross out 2 positive 3s? Oh yeah, let's go ahead and back up here. Oh yeah, that was an X plus 3. Okay, so since this was an X plus 3, we canceled it out, but then this is X cannot be also -3. So it's not positive 3. My apologies there. Not positive 3, just the 3 things that we canceled out. So thank you, Walter, for pointing that out for us. So -2, it's not allowed to be. 2, it's not allowed to be. -3, -3. So I just have to write them one time. I'm going to write them in order. -3, -2, and +2. Those are the 3 things that it is not allowed to be. Is how we got this part. So basically what we're saying here is this is our answer as long as X is not these things. As long as X is not -3, -2, or 2. Yes, thank you for the support there, everyone. Can I explain why I crossed out certain numbers? Yeah, I can. So I can cross out any factor that exists on top and on bottom because it's like crossing out 10 divided by 10 equals 1, right? Or like 4 divided by 4 equals 1, right? So 4 times 2 over 4 times 8 equals 2 over 8. Right, so if things are being multiplied together, like we saw in the beginning, we can cross them out. So all of the things that are being multiplied in the top here, all the things are being multiplied in the bottom there. So since I had X plus 3 here, I crossed it out with this one. I could have crossed out this one instead, but I chose to cross out this one. Doesn't really matter. Right, so X plus 3 and X plus 3 crossed out. And then I had X plus 2 on top here and X plus 2 on bottom here. So I could cross those out because those would make 1. Does that, sweet, awesome. Thanks for letting me know that that worked. All right, cool. All right, one last example. If you desperately need to go, I recognize it's 2:50, so you're more than welcome to head out. You can watch these 2 videos if you get confused. If you have an extra minute or 2, I would appreciate you sticking around. So we have dividing. Dividing is, we're gonna copy the first fraction, this turns into multiplication, and then we flip the second fraction. So I think maybe for some of you, this is where you were getting butterfly from. So we have 1/2, this one stays the same. This turns into a dot, multiplication, and this one gets flipped. So this would be 10 over 4, like that. So we have 1 times 10 would be 10. 2 times 4 would be 8. And then we simplify. So 5 over 4 would be our answer here. So when we are doing division, we are multiplying times the reciprocal, times the flipped version. So I'll give you a second to write this one down. So I would say this is x to the third plus 8, x minus 2 on the bottom. I'm going to change this to multiplication, and I'm going to flip these from top to bottom. So I'd have x squared minus 4x plus 4, and x squared, well, sometimes my iPad really hates me, x squared minus 2x plus 4. So I've turned it into multiplication, and now it is very similar to the problem before it. So I would have, I know this is the sum of cubes. So I have this is like x plus 2. So I would have x plus 2. Remember, it's your ombre formula. So x squared, 2x, and then 2 times 2 is 4, like that. And then remember that it's same, opposite, always positive, right there. I have x minus 2. That's the denominator here is turning into the denominator there. I still have my multiplication. I'm going to go ahead and split this one up. Something that multiplies to get positive 4, adds to get negative 4. I know it is negative 2 and negative 2. So I'd have x minus 2, x minus 2. So this portion here is turning into these two here. And then for this one here, I'm going to say, okay, I need to multiply to get 4, add to get negative 2. So I'm thinking 2 and 2, that's not going to work. 4 and 1, that's not going to work. So I don't think there's anything that will work for that. So I'm just going to write x squared minus 2x plus 4. So it does not factor. So I'm just going to leave it on the bottom like this. So I'm just using the colors to show you where each thing came from. So the blue turned into this blue factor set. The yellow didn't do anything, x plus x, just x minus 2. The red turned into this factor set, and the green, nothing we could do. So we just wrote the green again. So then from there, I am going to cancel out anything that I can. So for this case, I can see I have an x minus 2 here that can cross out with an x minus 2 there. And I actually see that this part of the blue and that green are the same. So I can go ahead and cancel out this part here and that part there. So I'd be left with just x plus 2 on the top and x minus 2 on the top. So I'd have x plus 2, x minus 2. I could write it over 1, but I don't need to because it's obviously over 1. There's nothing left over. And then we would have what x cannot be. X cannot be the thing that goes right here. So x minus 2, that would be positive 2. And then remember that this wasn't factorable. So that means that there are like 2 imaginary solutions. I know that they're imaginary because this came out of the difference of cubes. And remember, this thing is always going to be 2 imaginary solutions there. So it's not just because it's not factorable, but it's actually because it came out of here. So this would be my answer for this problem here for division. Okay, I know I went 5 minutes over. I really appreciate you guys sticking around. If you want to stick around and ask another question, you're more than welcome to. Otherwise, you do have an assignment today. It is in your Canvas page, and you are welcome to ask any questions that you have. Yes, so adios to those of you who are checking out. Question from the chat, can you explain why you put x plus 2 with this guy here? Yeah, so this, I went from this version to this version by doing the difference of cubes. So the difference of cubes we learned a few assignments ago, maybe assignment 11 or 12. And since I recognize this is x to the third and 8 is 2 to the third, then I'm able to use, just like we do difference of squares, like x squared minus 4 is x plus 2 and x minus 2. There's another trick called, or like factoring form called difference of cubes, which is our SOAP formula, which is like a very special formula. So that is where the special formula, difference of cubes, is where this section came from. I believe it was assignment 11. I'm almost positive. Assignment 11 will be where to find that. Yeah, for sure. Great question. All right, team. Those of you who are still here, bye. Bye, Caitlin. Bye, oh, Layla's already gone. Those of you who are still here, did you want to see an example? Or are you still just signing off? Do you want to do the first one together? Looks like we're signing off. Diana, Walter, you guys signing off, or you want to do an example? Gonna ask the last question. Oh yeah, okay. Sounds good, Walter. Yeah, no problem. Yeah, Diana, let's do one from the assignment. Do you want to do a simplifying one, a multiplying one, or a dividing one?
I prefer the dividing one.
Dividing one. Okay, let's do 16. Does that work?
Yeah.
Okay, cool. I'm gonna put down a sticky note here so I can type. There we go. Okay, so I'm gonna take this guy and put it here. I'm just gonna copy the first one. So I have x cubed plus 8 over 2x squared plus 4x. And then I'm going to change it to times because I need to do times instead of division. And then I'm going to flip this one. So the numerator becomes the denominator and denominator becomes the numerator. So I'd have 2x squared minus 6x on top and x squared minus 9 on bottom. Does that part make sense, Diana?
Yeah, it's the like reciprocal.
It's a reciprocal. Yeah. Yep. Good math word.
Mm-hmm.
So, okay, so we have the first part, right? This first part here, I need to put into its factored form. And I see that this is a cube and this is a cube. So this is the sum of two cubes. So that's the long formula that we just did. So it'd be x plus 2 because it's positive here and the cube root of this is 2. And then this is the first thing squared, so x squared. This is, the next term is the 2 times the x, so 2x. And the last one is 2 times 2, 2 squared, so it'll be 4, like that. And then the signs are the same as the problem, the opposite of the problem, so subtraction. And then the last one's always positive, so positive there. So that's how the first part went in there. Diana, does that part make sense? Do we feel okay about sum of cubes?
Yeah.
Okay, awesome. So then for this one, for the denominator of the first one, I see that there's only 2 terms, so I'm going to be thinking GCF. So for GCF, what can I take out of both? What can I divide out of both of these?
2.
2, and also?
X.
2x, yes. So then what would be left over?
X plus 2.
Yeah, perfect. Great job. All right, and then what about this part over here? What can I do with this?
We need to simplify it to like take out a 2x.
2x, and what would be left over?
X minus 3.
Perfect, good job. And then finally we have the last part. And what can we break that part into?
X and X. It's gonna be a 3, negative, and a plus.
Yep, positive 3 and negative 3, because it's the difference of squares. Yeah.
Yes.
All right. Is there anything that we can cancel out? Anything that's the same on top and on bottom?
The x plus 2.
The x plus 2 and x plus 2 for sure. And since I'm crossing, I'm gonna write x is not allowed to be -2 since I'm here. Anything else we can cross out?
So they're always gonna be like the opposite.
Yeah, always gonna be the opposite, just like the solution. So it's gonna be like x is not allowed to be 3 from this one, x is not allowed to be -3 from this one, and x is not allowed to be 0 from here. So once it's in its factored form, you can actually just do these things right away.
Okay. And then you can do x minus 3.
X minus 3 and x minus 3. There's one more thing you can cross out.
Oh, the 2x?
2x. So 2x over 2x is 1.
And then you just write
Uh-huh.
x plus 4. Well, you need a you don't need to factor that one out. Or
No, it's not going to be factorable because anytime that we have the sum or difference of cubes, it always has one small thing and one non-factorable trinomial.
Yeah.
So we have the trinomial over x plus 3 because we had this part and this part left over. And then I'm going to put in my warnings. So x is not allowed to be, I start with the smallest one, -3, then -2, then 0, then 3.
Okay, I got that now. I think
Great.
that was the only one. Thank you.
Okay. You're welcome. No problem. Let me know if you get stuck. Just text me.
Yes, thank you.
You're welcome. See you later.